All right, folks, get ready to blast off because today we are diving deep into the future of space construction. We're talking robots, satellites, and get this, the mind-blowing possibility of building things in space.
Yeah, it's pretty amazing stuff.
You guys have sent us a stack of articles about this, all about these robots that can repair and refuel satellites while they're still up in orbit.
That's right.
I mean, come on, it sounds like science fiction, right?
Absolutely, yeah.
But it's becoming a reality. So let's start with a satellite you might have heard of, Landsat-7. It's been over 20 years taking pictures of Earth, showing us everything from melting glaciers to deforestation. But then it ran low on fuel. And that's where things get really interesting. So why don't you tell us a bit about why that's such a problem, running out of fuel?
Well, the thing about satellites is that once they're launched, they're really difficult and expensive to repair or refuel. I mean, you launch them, they're up there, and that's kind of it.
Right.
And often, that means they just become space junk. Actually, one of the articles we looked at had this great analogy. They compared buying a satellite to buying a car that you can't refuel or repair for like 10 years.
Oh, can you imagine the sticker price on that car?
Yikes.
Yeah.
Exactly. Right. And that's kind of the problem. To compensate for the lack of, servicing options, we have to make these satellites with really redundant systems.
Right.
Load them up with tons of extra fuel. And all of that just drives up the cost of production and launch. And, it really drives it up. Modern communication satellites, they can cost up to $500 million.
$500 million.
Yeah. So you can see where this whole robotic mechanic thing comes in.
Right. It's like having a pit crew in space.
Yeah.
So how do these robots actually work? It can't be as easy as sending a mechanic to your local garage.
Well, you're not wrong there. One of the big challenges is that, you got to grab onto a satellite, and these satellites were never designed for docking.
Right.
It's like trying to grab a spinning top.
In zero gravity.
Exactly, in zero gravity. So what they're looking at is a lot of these older satellites, they have this aluminum ring that was used to attach the satellite to the launch vehicle.
Right.
And that they're targeting that ring as like the grabbing point.
Oh, that's pretty clever. So they're working with what's already there.
Exactly.
But, okay, there's another challenge that comes to mind. The whole time lag thing. Controlling a robot from Earth when it's in geosynchronous orbit has got to be a nightmare. It's got to be like playing video games with a terrible internet connection.
Yeah, the time lag is definitely a major hurdle. You can't control it in real time. So these robots, they need a really high degree of autonomy. They have to be able to think for themselves, at least to a certain extent.
Robots that think for themselves? That's a little unsettling, but also pretty cool. So give us an example. What's one of these complex refueling tasks look like?
Okay, so let's go back to Landsat-7. So these robotic refuelers, they would approach Landsat-7, and get this, they would cut through insulation, snip wires, unscrew a bolt, and then they'd attach a hose to pump in fresh hydrazine fuel.
Hold on, they're going to be performing surgery on a satellite that's been up there for over 2 decades. That's mind-blowing. One of the articles even quoted someone saying, "We never thought anybody would ever touch that interface again."
And that really highlights what we're talking about here. It's groundbreaking technology. It means we might be able to bring back these satellites we thought were lost forever. But it's not just about refueling. They can do even more.
Okay, yeah, you mentioned in-orbit construction earlier. Tell me more about that.
Okay, so NASA has this mission called OSAM-1. And this mission has a really fascinating secondary objective. It involves a robot called Spider the Space Infrastructure Dexterous Robot.
The name alone is just fantastic.
Right. And what it's going to do is actually demonstrate that we can assemble structures, like build things in orbit. It'll assemble this 3-meter antenna in space as a proof of concept.
So we're talking about, actual construction in space. That's incredible. How does that even work?
Well, OSAM-1, it's going to use this process that's kind of like 3D printing.
Okay.
It's going to create these strong, lightweight beams from spools of carbon fiber. It's like building with Legos, but on a cosmic scale.
Okay, my mind is officially blown. I'm picturing giant space stations, fuel depots, maybe even a spaceship to Mars.
You're getting it. The potential is huge. And it goes way beyond just exploration. We could have solar power arrays beaming clean energy back to Earth, or massive telescopes that can see farther into the universe than ever before.
Okay, hold on, my head's spinning. We need to pause here for a second.
I get it.
We've covered so much ground already, it's a lot to take in.
It is.
So let's take a breath. Let's take a step back and really think about what all of this means.
Absolutely.
Because we're not just talking about robots in space, we're talking about changing how we approach space exploration, infrastructure, and even resource management here on Earth.
Right, it really has that potential.
You're right, we could be talking about changing the future of humanity's relationship with space. But before we get too far ahead of ourselves,
Yeah.
I'm still a little stuck on the building things in space part. It's just so cool.
I know.
Can you give us some more details on how that would work? What are the limitations and what are the benefits?
Of course, let's dig into that a bit further. One of the biggest advantages is we don't have to worry about launching things from Earth with all those size and weight restrictions.
Right, you can't just launch a fully assembled space station, be like trying to cram a giant elephant into a smart car.
Exactly.
Right.
Building things in orbit lets us create structures way bigger and way more complex than anything we could launch in one piece.
And I'm guessing it's probably a lot cheaper too, right? Launching all that material must get expensive.
You're absolutely right. The heavier the payload, the more it costs to launch.
Makes sense.
But imagine if we could get our building materials from space itself, mining resources from asteroids or the moon, using those materials to build directly in orbit.
Hold on, so we're not just building in space, we're sourcing our materials in space.
Exactly.
Wow, suddenly all those sci-fi stories about asteroid mining don't seem so far-fetched.
Not at all. We're talking about space stations, telescopes, even fuel depots, all built with materials we find out there.
It'd be a game changer. But, okay, let's not get too carried away. There got to be some risks, right? I mean, building anything is complicated, and I bet space throws in a whole new set of challenges.
Oh, absolutely. You have to be realistic about the challenges. Space is a pretty harsh environment. You've got radiation, extreme temperatures, micrometeoroids. It's not easy.
Yeah, it's like building a house in the middle of a hurricane. But instead of wind and rain, you have cosmic radiation and these tiny, super fast bullets whizzing around.
It's a good analogy. It's a tough environment, but that's part of what makes it so exciting. It's pushing the limits of engineering and innovation.
Okay, so building in space is tough, but what about the human element? Will we need astronauts up there to actually assemble these things, or can the robots handle it all?
It'll probably be a mix of both. I mean, for simpler tasks, robots are perfect. They don't need life support. They can work 24/7, and they're not as vulnerable to the dangers of space.
Right.
But for the really complex stuff or anything delicate, you'll still need that human touch, that dexterity and problem solving.
So we're looking at a future where robots and humans are working side by side, like a cosmic construction crew.
It is exciting to think about.
But before we start planning our space vacations, there's another big question. Who owned all this stuff we're building? Who gets to decide what gets built and where? It's a whole legal and ethical can of worms.
You're bringing up some crucial points. As we expand into space, we have to think about the consequences. Who owns the resources? How do we keep space peaceful? These are questions we need to be asking now.
It's like writing the rules of the road for a whole new highway system. We got to make sure everyone benefits, not just a select few.
Absolutely.
But you mentioned earlier that this technology could also have applications back here on Earth. Can you elaborate on that?
Definitely. The possibilities are enormous. Think about it. More efficient communication networks, better weather forecasting, better disaster response systems,
Right.
and even new manufacturing techniques, using the unique conditions of space to create things we never could on Earth.
Wow. We're talking about revolutionizing life on Earth, even if we never set foot on another planet.
It's amazing to think about.
But let's not get ahead of ourselves.
Yeah.
There's still a long way to go before we see all these benefits. So where do we go from here? What are the next steps in making all this happen?
The key is to keep investing in research and development. We need to keep refining the robotic technologies, developing new materials, and really testing these concepts in space. And maybe even more importantly, we need to work together. Governments, private companies, research institutions, we all need to collaborate.
Like a global team effort.
Exactly.
We've seen time and again, the biggest achievements come when people work together, sharing knowledge and resources. But as we've talked about, it's not just about the tech. We need to have those tough conversations about ethics, regulations, and sustainability to make sure we're doing this right.
Absolutely. It has to be done responsibly.
Okay, so we've covered a lot.
We have.
But before we move to the next phase of our deep dive, let's zoom in on one aspect of in-orbit construction: the materials. What are the most promising materials for building these structures in space, and what makes them so special?
Great question. Choosing the right material is crucial, and researchers are looking at a whole bunch of options. One of the most promising is carbon fiber, because it's super strong and lightweight.
Right. Makes sense. We already use it in airplanes and spacecraft here on Earth.
Exactly. But there are other contenders, too. We're talking about advanced alloys, inflatable structures. They're even looking at using lunar regolith.
Wait, what's that?
It's the loose material on the moon's surface.
Oh, so like using the moon as a giant quarry for our space construction project.
Exactly.
That's wild. It seems like there's a whole new world of material science opening up just for space construction.
It is a really fascinating field.
It is. But let's shift gears for a second and talk about the economics of all this. How will robotic servicing and in-orbit construction change the space industry?
This tech has the potential to completely change how we do things in space. First, it could make launching and maintaining satellites much cheaper, opening up space to more players.
So more people and organizations would have a chance to be part of this whole space thing.
Exactly. We could see a democratization of space.
That's an awesome idea.
And second, it could lead to entirely new industries and markets. Companies specializing in robotic servicing, in-orbit construction, even space-based manufacturing.
Wait, so we're not just talking about fixing satellites anymore. We're talking about a space-based industrial revolution.
You got it. The possibilities are endless.
It sounds like we're on the verge of something really big. But let's not forget about the scientific potential here. How will this tech help us understand the universe better?
The scientific benefits are huge. Think about building larger and more powerful telescopes in orbit.
Okay.
We could see further and deeper into the cosmos, unlock new mysteries, maybe even find evidence of life on other planets.
Wow, now that's a scientific advancement I can get behind. Finding aliens.
Yeah.
Who knows what we might discover? And it's not just telescopes. We could build space-based labs, do experiments in microgravity, study the sun and other planets with instruments way too complex to launch from Earth.
So it's a giant leap for science, all thanks to robots and construction in space.
You could say that?
It's incredible. But let's bring it back down to Earth for a second.
Okay.
How will all this stuff going on in space affect our lives down here?
Well, the potential benefits for humanity are huge. Just think about it. More efficient communication networks, better weather forecasting, better disaster response.
We could even see new manufacturing techniques developed in space, leveraging microgravity and vacuum conditions to create breakthroughs in materials and products that could benefit everyone.
Wow, it's mind-blowing to think that building things in space could make such a big difference in our lives here on Earth. It's a good reminder that exploration and innovation often lead to unexpected benefits for everyone.
You're absolutely right.
But let's be real, there are some potential downsides or risks we should be aware of as we explore this new frontier, right?
Of course. It's important to be thoughtful and responsible as we develop this technology. One potential risk is space debris.
Right, all that junk floating around up there.
As we launch more objects and build more structures in orbit, the risk of collisions increases. That debris can damage other satellites and spacecraft. We need to figure out ways to deal with that risk.
So it's like we're solving one problem but creating another one.
It's something we need to be mindful of.
And what about the possibility of this technology being used for, not so good purposes? Like, could it be used for military things?
That's a valid concern. As with any powerful technology, there's potential for misuse. We need to have international agreements and rules of behavior to make sure that space stays peaceful.
It's like the Wild West out there. We need some law and order in space.
It's an important conversation to have.
Definitely. But let's not forget about the amazing potential benefits. A thriving space economy, building and exploring new worlds, using space tech to improve life on Earth. It's a future worth working towards.
It is a really inspiring vision.
It is. But before we wrap up this part of our discussion, let's take a look back. How do we get to this point where we're talking about robots building things in space? What were the key moments and breakthroughs that led us here?
Well, it's been a long journey, full of scientific advancements and innovations, all driven by this human desire to explore.
Right, from the first rockets to the first satellites to those incredible Apollo missions, it's been a wild ride.
It really has.
But what were some of the specific breakthroughs that made robotic servicing and in-orbit construction possible? It's one thing to send a probe to Mars, but building something in space seems like a whole other level.
Absolutely. One major milestone was the development of robotic arms for use in space. Think about the Canadarm, which was essential for building and maintaining the International Space Station.
Oh, yeah. I remember seeing those images, this giant robotic arm maneuvering those massive modules of the space station. It was amazing.
It was a truly remarkable achievement.
It was.
And then there's the development of autonomous robots, like those Soviet Lunokhod rovers that explored the moon back in the 70s, and of course the Mars rovers we have today. Each mission has taught us more about how to make robots that can think for themselves, paving the way for even more complex missions in the future.
So we've been sending robots to explore the solar system for over 50 years. But what about the idea of actually building things in space? When did that first come up?
The idea's been around for ages, but it's only recently that it's become possible. We started with things like large antennas in space, assembled from multiple parts. But the real game changer was the development of 3D printing and other advanced manufacturing techniques.
Okay.
That's what makes it possible to build complex structures in orbit using lightweight and easy-to-transport materials.
So it's like all these different technologies, robotics, autonomy, 3D printing. They're all coming together to make this vision of in-orbit construction a reality. It's pretty amazing what humans can do when we put our minds to it. But as we move forward, are there any lessons from our past space explorations that we can use?
Absolutely.
Anything we can learn from our successes and failures to make sure we don't make the same mistakes?
Absolutely. I think one of the most important lessons is to test everything thoroughly. The space environment is harsh, and mistakes can be really costly. We have to make sure every component and system can handle the stress of spaceflight. And we also need to be prepared for the unexpected.
Right, because things don't always go according to plan, especially in space.
Exactly. We need to be flexible and adaptable, design systems that can handle surprises, and that can be fixed in space. And of course, international cooperation is key. Space exploration has always been a global effort.
Right, we're all in this together.
The challenges are too big for any one country to handle alone.
So true. But let's talk about the role of private companies in all of this. They seem to be playing a bigger and bigger part in space exploration. How are they contributing to robotic servicing and in-orbit construction?
Private companies are becoming major players in the space industry. They're developing new technologies, launching rockets, even building their own spacecraft.
It's pretty amazing how much things have changed.
Yeah. And when it comes to robotic servicing and in-orbit construction, companies like SpaceX, Blue Origin, and Northrop Grumman are making huge contributions.
What are some of the things they're doing that are particularly interesting?
Well, SpaceX is developing its Starship, which is designed to be fully reusable and can carry huge payloads to orbit.
So if we need to get a lot of building materials up there, Starship's the way to go.
Exactly. Cheap and efficient transportation is key. And then there's Blue Origin. They're not only working on their own heavy lift rocket, New Glenn, but they're also investing in space infrastructure.
Right, that's their orbital reef project, a commercial space station.
Exactly. It's a bold idea. Basically a business park in space.
Wow.
Another great example of how private companies are driving the future of space.
And what about Northrop Grumman? They're the ones with those robotic space tow trucks, right?
You got it. The Mission Extension Vehicles, or MEVs, they've already shown they can extend the life of satellites, and they're also key in developing technologies for in-orbit assembly and manufacturing.
Like their space infrastructure dexterous robot, Spider.
Yes.
The one that's going to assemble that antenna in space.
That's the one. It's a test mission, but if it works, it means we could be building much bigger things in orbit, like telescopes, solar panels, even habitats.
So we've got companies providing the heavy lifting to get materials into space, private companies building space stations, and robots assembling structures all on their own. It's incredible.
It really is a new era for space.
It is. But it's not just about the technology.
No.
It's also about what we do with it. What are the possibilities? What could we be building up there?
Well, imagine massive space-based factories. We could take advantage of microgravity and the vacuum of space to create products that are impossible to make on Earth.
Okay, so we're talking about made-in-space products. I can already see the commercials. But seriously, what kind of products are we talking about?
Well, think about things like fiber optic cables that are perfectly clear, super pure pharmaceuticals, alloys that are way stronger and more durable.
So life-saving medicines, super strong building materials, space could become the ultimate manufacturing hub.
It really could.
That's incredible. But let's be real for a second. This is all super exciting, but it's not all sunshine and roses. There are going to be challenges, right? What are some of the ethical concerns and risks we need to be thinking about as we move forward with this?
Well, we've talked about space debris, and that's a big one. But we also need to think about the ethical implications of all this.
Right, because we don't want to just repeat the mistakes we've made here on Earth.
Yes.
We need to make sure that developing space benefits all of humanity.
It needs to be sustainable and responsible.
So it's about finding that balance.
Yeah.
Pushing the boundaries of what's possible while making sure we're doing it the right way.
That's the key.
It's definitely a challenge, but I'm optimistic. I think we can do this.
Me too.
The future of space construction has so much potential for everyone. It's a reminder that humans are pretty good at overcoming obstacles. But as we continue this discussion, it's important to remember that this isn't just about technology. It's about humans exploring a new frontier, expanding our understanding of ourselves and our place in the universe. And that's a journey worth taking.
It really is.
So with that in mind, let's dig a little deeper into one of the biggest challenges of working in space, the environment itself. We've touched on it a bit, but can you tell us more about what makes space such a difficult place to work in and how we're overcoming those challenges?
Sure. The space environment is incredibly harsh, full of challenges we just don't face here on Earth. For starters, there's the vacuum of space. No air to breathe, no air pressure, no protection from the sun's radiation.
It's a tough workplace. It's like trying to build a house in the middle of a desert, but 1,000 times more extreme.
Exactly.
How do you even design structures that can survive in that kind of environment?
It takes incredible planning and a deep understanding of materials. You have to choose materials that can handle wild temperature swings. Something in space can go from super hot in direct sunlight to freezing cold in the shade, all within minutes.
I never thought about that. That kind of temperature change would destroy most things. What kind of materials can handle that?
We're talking about special alloys, composites, even some exotic materials that are still being developed. The key is to find something strong, lightweight, and resistant to both heat and cold.
Makes sense.
And then you have to deal with radiation. Space is full of harmful radiation from the sun and other cosmic sources.
Right.
So we have to protect sensitive electronics and other components. It means building radiation shielding into everything we send up.
It's like building a suit of armor for your spacecraft.
Yeah.
But it can't be too heavy or bulky to launch.
Right. It's a balancing act.
So we have to build something that can function in the harshness of space.
Yeah,
But it also has to survive the trip getting there.
that's right.
It's amazing anything survives launch at all. Those rockets generate so much force and vibration. How do you design for that?
Launch is definitely one of the most critical phases of any space mission.
I bet.
You have those intense vibrations and G-forces that can damage or destroy delicate parts. Everything has to be built to withstand incredible stress.
It's like designing a building to survive an earthquake, but much, much stronger.
Exactly.
So we have to think about the launch, the extreme temperatures, the radiation. Are there any other hazards in space we need to worry about?
Oh, absolutely. There's the constant threat of micrometeoroids and orbital debris.
What are those?
Well, micrometeoroids are tiny particles of dust and rock zipping around at super high speeds.
Oh, are we?
Even a tiny one can cause a lot of damage to a spacecraft.
Ouch.
And then you've got orbital debris, which is basically space junk from old satellites and rocket parts. That stuff poses an even bigger threat.
So it's like navigating a minefield, but in space. How do engineers protect spacecraft from all this stuff?
It's a multi-layered approach. We use protective shielding, backup systems, even materials that can repair themselves if they get damaged.
Wow, self-healing spacecraft. That's incredible.
He's pretty amazing.
It is, but it's a constant battle against the harsh realities of space.
Absolutely.
But I guess it's a battle worth fighting, considering all the potential benefits.
The rewards are definitely worth it.
So let's talk about working with robots in this crazy environment. We've talked about robots servicing and building things, but how do you even control and maintain robots that are hundreds or even thousands of miles away?
That's one of the biggest challenges we face. Communication delays are a huge problem.
Right.
So controlling them in real time, like we do with drones here on Earth, just isn't possible.
So how do you control them? Do you have to program every single movement beforehand and hope for the best?
That's where autonomous systems come in. We're talking about robots that can perform tasks with very little human input. They use sensors, artificial intelligence, and complex algorithms to make decisions and adapt to changing conditions on their own.
So they're not just following a set of instructions. They can actually think for themselves.
In a way,
That's both impressive and a little scary. But what about maintenance?
Yeah.
What happens if a robot breaks down in orbit? Sending a repair crew every time something goes wrong would be ridiculously expensive.
Absolutely. That's where things get really tricky. One approach is to design robots that are modular and have redundant systems.
Oh.
If one part breaks, you can easily swap it out. Maybe another robot could even do the repairs.
Like a robotic pit crew in space. That's awesome.
It's one possibility. Or, in some cases, astronauts could do the repairs during a spacewalk. But it's not just about fixing things when they break. What about regular maintenance to keep these robots working properly over long periods in that harsh environment?
That's a good point.
It all comes down to good design. We need to build robots that are tough, reliable, and easy to maintain. Things like self-diagnosing systems, designs that can tolerate faults.
So robots that can basically tell you what's wrong with them and fix themselves.
Well, we're not quite there yet, but it's definitely something researchers are working on.
That's amazing.
It's a really exciting field with so much potential.
It sounds like building robots for space is almost as challenging as building the structures themselves.
It definitely has its challenges.
But despite all these challenges, the benefits of robotic servicing and in-orbit construction seem to outweigh the risks.
I agree.
It's a technology that could change how we explore and use space forever.
I think so too.
And it shows how resourceful and determined humans can be. We're pretty good at overcoming even the toughest obstacles. But as we continue exploring this topic, it's important to remember that this is more than just about technology. It's about humans pushing the boundaries of what's possible. It's about expanding our understanding of ourselves and our place in the universe. It's a journey worth taking.
Absolutely. It's a journey that will challenge us in ways we can't even imagine. But it's also a journey that will inspire us, push us to think differently, and ultimately it will lead us to a deeper understanding of ourselves and our place in the cosmos.
Beautifully said. But before we move on, let's take a moment to consider the bigger picture. How will this technology impact our lives back here on Earth? I mean, we've talked about the practical applications, but what about the philosophical implications? How will this change how we see ourselves and our place in the universe?
That's a really important question.
It is.
This technology has the potential to completely change our relationship with space.
Okay.
Right now, we think of space travel as these short trips, a quick visit to the ISS, or sending a robot to Mars. But imagine if we could build large structures in space. We could have a sustained presence out there, not just visiting, but living and working.
Right. Instead of thinking of space as this hostile environment, it becomes a place where we can actually build a future.
Exactly. Suddenly, those sci-fi ideas of moon bases and Mars settlements start to feel more real.
And it's not just about living in space, it's about resources, right?
Absolutely. If we can mine asteroids and use lunar regolith for construction, it could take a lot of pressure off of Earth's resources, making our planet more sustainable.
It's kind of like the age of exploration on Earth. At first, it was just about the voyage, the unknown. But then people started building settlements, establishing
Trade routes, and the world felt smaller, more connected. Could space construction be the spark for a similar transformation in our relationship with space?
It's an amazing thought. Space could become a part of human civilization, a place where we can grow and innovate. But, like we've talked about, with this incredible potential comes responsibility.
You're absolutely right. We can't just charge into this new frontier without thinking about the ethics, the environmental impact, the laws that will guide our actions. It's not enough to ask what we can build. We have to ask how we should build it and why.
So for our listeners who's been with us on this journey, exploring this incredible future of space construction, we leave them with a challenge. As we enter this new era, let's not just be amazed by the technology, let's have those crucial conversations that will shape the future we build among the stars.
A future where space is more than just a destination. It becomes a canvas for our dreams, our aspirations, our shared human story.
That's a beautiful way to put it.
Yeah.
Okay, back down to Earth for a minute. You were about to say something about the economic impact of all this.
Right. It's a complicated topic. There are some exciting possibilities, but also some challenges we need to be aware of.
Exactly. We've talked about this incredible future in space, but what does it mean for people here on Earth? What about jobs and new industries?
Well, one thing is that this technology could create entirely new sectors of the economy. Imagine companies that specialize in robotic servicing, in-orbit construction, even manufacturing in space. These aren't just science fiction fantasies anymore. These are real opportunities emerging.
So we're not just talking about rocket scientists and astronauts anymore. We're going to need a whole new workforce to make this space-based economy happen.
Exactly. Engineers, technicians, programmers, you name it. And these will be high-skill, high-paying jobs that can boost economies around the world.
Sounds great, but I'm sure it's not all good news, right? What's the downside?
Well, as space-based technologies become more efficient and affordable, some traditional industries might see job losses. Think about satellite manufacturing. If robots are building satellites in orbit, that impacts factories and workers down here on Earth.
So it's a double-edged sword. Exciting new opportunities, but also some potential disruptions we need to be prepared for.
That's exactly it. We need to be proactive about investing in education and retraining programs so that workers have the skills they need for these new space-based industries.
So it's like any technological revolution. We have to figure out how to manage the transition smoothly. Okay, so that's the economic side of things. But this technology also has incredible scientific potential. We touched on it earlier, but I'd love to hear more about the kind of scientific advancements this could lead to.
Well, think about telescopes. Right now, the size of the telescopes we can launch from Earth is limited by the size of our rockets. But if we can build them in orbit, using those lightweight materials and robotic assembly we talked about, we could create telescopes that are much larger and more powerful. Imagine the possibilities.
We could look deeper into the universe, unravel the mysteries of the cosmos, maybe even find evidence of life on other planets. That's a scientific advancement I'm all for.
Exactly. And it's not just limited to telescopes. Imagine space-based laboratories where we can conduct experiments in microgravity or special observatories with instruments too complex to launch from Earth, giving us new insights into the sun and other celestial bodies.
Wow, it's like unlocking a whole new level of scientific discovery. I'm adding, build a giant space telescope to my bucket list.
I wouldn't be surprised if that becomes a popular bucket list item.
Mm-hmm.
But speaking of things we've talked about, you had some great questions earlier about specific companies and their technologies. Would you like to revisit those?
Yes, absolutely. We've mentioned SpaceX, Blue Origin, Northrop Grumman. What are some of the groundbreaking things they're doing in this field?
Each company is focusing on different areas, but they're all pushing the boundaries of space construction in exciting ways. SpaceX, for example, is developing its Starship, which is designed to be fully reusable and capable of carrying enormous payloads to orbit.
So if we need to transport construction materials to space, Starship is like the ultimate heavy-duty truck.
That's a perfect analogy. This cost-effective transportation is going to be essential for large-scale construction projects in space. Then there's Blue Origin, which is developing its own heavy-lift rocket called New Glenn. But they're also investing in space infrastructure itself.
Right, you're talking about their Orbital Reef project, the commercially developed space station.
Exactly. It's an ambitious project. They want to build a mixed-use business park in low Earth orbit. It shows how private companies are becoming major players in shaping the future of space.
And Northrop Grumman, they're the ones with those robotic space tow trucks, the mission extension vehicles, or MEVs.
That's right. They've already demonstrated their ability to extend the lifespan of satellites. And they're also a key player in developing technologies for in-orbit assembly and manufacturing.
And that includes their space infrastructure dexterous robot, Spider, that we discussed earlier, the one that will assemble that 3-meter antenna in space.
Exactly. It's a proof of concept mission. But if it's successful, it opens the door for building much larger structures in orbit. Telescopes, solar power arrays, even habitats.
So, to summarize, we've got heavy-lift rockets to transport materials to orbit, private companies building space stations, and robots assembling structures on their own. It sounds like we're on the verge of a whole new era of space construction.
It's a really exciting time to be following the space industry, and it's not just about the technology itself, it's about what we can do with it. The possibilities are incredible.
Okay, I'm ready for more mind-blowing possibilities. What else could we build in space?
Well, imagine huge manufacturing facilities in space. The microgravity and vacuum conditions out there create unique opportunities for certain types of production. We could create products with properties that are just impossible to achieve here on Earth.
So, made in space is going to be more than just a marketing slogan. We're really talking about manufacturing in space.
Absolutely. What kind of products? Think about things like fiber optic cables with perfect clarity, incredibly pure pharmaceuticals, alloys with strength and durability beyond anything we can create down here. The list goes on and on. The unique environment of space allows us to explore a whole new world of materials science and manufacturing.
Wow. So space could become the ultimate manufacturing hub. From life-saving medicines to super strong building materials, the possibilities are incredible. But let's be realistic for a moment. This is all very exciting, but I'm sure there are some challenges ahead, right?
Of course. We've touched on the ethical considerations and the problem of space debris. These are issues we need to think about very carefully as we move forward.
It's about finding that balance between pushing the limits of innovation and making sure we're doing it in a way that's sustainable and responsible. It's a challenge, but I think we can do it.
I agree. It's going to take collaboration, foresight, and a real commitment to ethical development. But if we do it right, the future of space construction holds incredible promise for humanity.
This has been an amazing conversation. So much to think about. But before we wrap up, I have one last question for you. What if the biggest impact of all this isn't about what we build, but about how it changes our relationship with space itself?
That's a really profound thought.
I mean, right now we think of space travel as these short trips.
Right.
You know, a quick visit to the ISS, a robotic mission to Mars.
Yeah.
But what if, with large-scale construction, we could actually shift from temporary visits to a more permanent presence?
It would be a huge change. We wouldn't just be dipping our toes in the cosmic waters anymore. We'd be establishing ourselves in space.
Exactly. It wouldn't be this hostile environment we briefly venture into. It'd be a place where we live, work, build a future.
And those sci-fi concepts of lunar bases or Martian settlements, suddenly they don't seem so far-fetched.
Exactly. And it's not just about living in space. Think about how it could change the way we manage resources.
Right.
If we're mining asteroids, using lunar regolith for construction, that could really lessen the burden on Earth's resources.
Absolutely. It could help us create a more sustainable future here on Earth.
It's almost like the age of exploration on Earth, but in reverse. At first, it was all about the voyage, the unknown.
Yeah.
But then settlements were built, trade routes established, the world felt smaller, more connected. Could in-orbit construction be the thing that kickstarts that kind of transformation in our relationship with space?
It's certainly possible. Instead of being this distant, abstract idea, space could become an extension of human civilization, a place of opportunity, a place to grow.
It's mind-blowing, but like we've said throughout this whole discussion, with great power comes great responsibility.
Absolutely. We can't just rush into this new frontier blindly. We have to think about the ethical implications,
Right.
the environmental impacts, the legal frameworks that will guide us. It's not just about what we can build, but how we build it and why.
So for our listeners who've been with us on this journey, exploring the amazing world of space construction, we leave you with this thought. As we enter this new era, let's not just focus on the technological achievements. Let's also have those important conversations about the future we're building in space.
A future where space isn't just a place to go, but a place to create, to dream, to build a new chapter in the human story.
That's a perfect way to end this conversation. Well, folks, that brings us to the end of our deep dive. We hope you enjoyed exploring the future of space construction with us.
And we hope it's inspired you to keep looking up, keep asking questions, and keep exploring the vast possibilities that are out there.
Until next time, keep diving deep.